Every now and then a question makes it into a mathematics exam that really shouldn't. My first mathematics exam that I wrote as a newly qualified graduate teacher, I made an error in one of the questions. At least 1 in 3 mathematics exams that I see will have an error, and very often we don't discover it until a student in the exam goes, "Hey sir, can you explain this to me?" Sometimes we don't discover it until we're marking it. It happens. Teachers make mistakes. It's an incredibly important learning opportunity, however. Here's a question that I saw in an exam recently. You've got a ship leaving port. It's sailing at 065 degrees true. It travels 22 kilometers from this port. The ship is now 15 kilometers directly east of an observer who is an unknown distance north of the port. We're asked to find out how far north of the port the observer is. Well, the solution set said, well, we start by looking at x, which is the distance that the observer is from the port, and we divide that by 22, which is the distance that the ship is from the port, and that will give us cosine of 65 degrees. If you follow that all through, you get x is about 9.30 kilometers. There's another way, of course, to do the problem, and you could use the tan ratio and say, well, the ship is 15 kilometers east of the observer, and it's x kilometers north of the port. So 15 over x is tan 65. And if you follow that all through, you get x equals 6.99 kilometers. And this is the point that I started to have questions. Then I thought, hang on a second, let's just see how far the ship really is east of the observer if it's traveled 22 kilometers on a track of 065 degrees true. So you would have the distance east over 22 is sine 65 degrees. And that's going to tell you that the ship is in fact not 15 kilometers east of the observer. It's more like 19.94. Of course, there are many calculators on the internet, and you can put them in and go, is this triangle feasible? Is this real? And this is what we call an impossible triangle. It cannot exist in the real world. There's one more way of finding out what the x distance could be, and that is if you say, well, the hypotenuse of this right-angled triangle is 22 kilometers, and the short side on the top is 15. Allegedly, it clearly isn't, but let's just pretend that it is. Well, you can use Pythagoras, and then you have that the x distance is 16.09 kilometers. So in fact, there's not one, there are not two, but there are 3 potential answers to this question. And you can make the argument that all of them are nonsense because the triangle literally cannot exist in the real world. So it's an interesting observation, isn't it? You never reach the point where you make no mistakes, but I would suggest that if you're not willing to make a mistake, you're not willing to do much.